Module 2, Networks and Decision Mathematics. Question 1. Which one of the following graphs contains a loop? By inspection, we notice that the only graph that contains a loop is the graph in option B. So the answer is option B. From the 2017 VCAA examination report, 92% of the students chose the correct option. So this question was answered extremely well. Question 2. Two graphs labeled Graph 1 and Graph 2 are shown below. The question is asking to compare the sum of the degrees of the vertices of Graph 1 to the sum of the degrees of the vertices of Graph 2. Let's start by determining the degrees of the vertices in Graph 1. The 4 vertices are of degree 3 each, which means that the sum of the degrees of the vertices of Graph 1 is 12. Now let's check the degrees of the vertices in Graph 2. Each vertex in Graph 2 is of degree 2, which means that the sum of the degrees of the vertices of Graph 2 is 12 as well. So the answer we are after is option C. The sum of the degrees of the vertices of Graph 1 is equal to the sum of the degrees of the vertices of Graph 2. From the 2017 VCAA examination report, 83% of the students chose the correct option. So this question was answered very well. In question 3, we are given a graph and its adjacency matrix with some elements missing, as shown in the matrix below. This adjacency matrix contains 16 elements when complete. The question is asking for the 12 missing elements. Let's start with vertex W. There is a loop here. This is why there is a 1 in row 1, column 1. There are 2 edges between W and X, so there is a 2 in row 1, column 2, and another 2 in row 2, column 1. There are 2 edges between W and Y, so there is a 2 in row 1, column 3, and another 2 in row 3, column 1. There is 1 edge between W and Z. This gives a 1 in row 1, column 4, and another 1 in row 4, column 1. Now let's look at vertex X. There are no loops. For this reason, there is a 0 in row 2, column 2. There is 1 edge between X and Y, so there is a 1 in row 2, column 3, and another 1 in row 3, column 2. There is 1 edge between X and Z, so there is a 1 in row 2, column 4, and another 1 in row 4, column 2. When we look at vertex Y, we notice that there are no loops, and this is why there is a 0 in row 3, column 3. There is 1 edge between Y and Z. For this reason, there is a 1 in row 3, column 4, and another 1 in row 4, column 3. Z has a loop. For this reason, there is a 1 in row 4, column 4. So the answer we are after is option A, 8R1 and 4R2. From the 2017 VCAA examination report, 92% of the students chose the correct option. So this question was answered extremely well. Use the following information to answer questions 4 and 5. The directed graph below shows the sequence of activities required to complete a project. The time to complete each activity in hours is also shown. Question 4. Determine the earliest starting time in hours for activity N. To do that, we need to look at the activities that need to be completed before activity N from start to finish. These activities are C, G, F, I, J, and K. Let's start with activity C. The earliest starting time for activity C is 0. 0 plus 4 equals 4, which gives the earliest starting time for activity G, which is 4, and the earliest starting time for activity F, which is 4 as well. Following activity G, 4 plus 3 equals 7. This means that the earliest starting time for activity I is 7, and the earliest starting time for activity J is 7 as well. Following activity F, we have 4 plus 6 equals 10, and following activity I, we have 7 plus 2 equals 9. We have to choose the activity with the longest time in order to determine the earliest starting time for activity K. That is 10, so the earliest starting time for activity K is 10. Now, following activity K, we have 10 plus 1 equals 11, and following activity J, we have 7 plus 5 equals 12. Again, we choose the activity with the longest time, which is 12. So the earliest starting time for activity N is 12. So the answer we are after is option D, 12. From the 2017 VCAA examination report, 65% of the students chose the correct option. Question 5. To complete the project in minimum time, some activities cannot be delayed. The question is asking for the number of activities that cannot be delayed. So what we are going to look for is the activities on the critical path. Let's start by determining all the earliest starting times for all the activities remaining. Activities A and B have an earliest starting time of 0. Following activity B, we have 0 plus 4, which is 4. So the earliest starting time for activity D is 4. The earliest starting time for activity E is also 4. Following activity A, we have 0 plus 10, which is 10, and following activity D, we have 4 plus 5, which is 9. In order to determine the earliest starting time for activity L, we need to choose the activity with the longest time, which is 10. We now follow activity E, so 4 plus 4 equals 8, and from H, with an earliest starting time of 10, we have 10 plus 3 equals 13. In order to determine the earliest starting time for activity M, again we choose the activity with the longest time, which is 13. Following activity L, we have 10 plus 6 equals 16. Following activity M, we have 13 plus 4 equals 17. We now need the earliest starting time for activity O, and that is 12 plus 3, which is 15. Following activity O, we have 15 plus 1 equals 16. Again, we are going to choose the activity with the longest time, so the finish time is 17. We now need to determine the latest starting time for all the activities. So we are going to go backwards from 17, take away 6 equals 11, the latest starting time for activity L, and then 11 minus 10 equals 1, the latest starting time for activity A. The latest starting time for activity D is 11 minus 5, which is 6. And now we go to activity M. 17 minus 4 equals 13. We can now determine the latest starting time for activity E, which is 13 minus 4 equals 9. In order to determine the latest starting time for activity B, we choose the activity with the shortest time. So we have 6 minus 4 equals 2. To determine the latest starting time for activity O, we have 17 minus 1, which is 16. For activity N is 16 minus 3 equals 13. We can now determine the latest starting time for activity K, which is 13 minus 1 equals 12, and the latest starting time for activity H, which is 13 minus 3 equals 10. The latest starting time for activity J is 13 minus 5, which is 8. The latest starting time for activity F is 10 minus 6, which is 4. The latest starting time for activity I is 10 minus 2, which is 8. And the latest starting time for activity G is 8 minus 3, which is 5. Now the latest starting time for activity C is 4 minus 4, which is 0. We can now see the critical path, which contains activities C, F, H, and M. So the answer to this question is option C, 4. From the 2017 VCAA examination report, 51% of the students chose the correct option, with 20% of the students choosing the incorrect option B and 13% of the students choosing the incorrect option D. Question 6. An Eulerian trail for the graph above will be possible if only one edge is removed. The question is asking, in how many different ways could this be done? A graph has an Eulerian trail or Eulerian path if all its vertices are of even degree or if it has exactly two vertices of odd degree. Let's start by labeling the vertices A, B, C, D, E, and F. Now we are going to determine the degrees of each vertex. A, degree 3, B, degree 5, C, degree 5, D, degree 5, E, degree 4, and F, degree 4. Notice that there are 4 vertices of odd degree. Let's start by removing the edge AB. This makes vertex A of degree 2 and vertex B of degree 4. So now we have exactly 2 vertices of odd degree, C and D. So this is the first way of making an Eulerian trail possible in this graph. Now we are going to remove edge BC. This makes vertex B of degree 4 and vertex C of degree 4 as well. There are exactly 2 vertices of odd degree, A and D, so this is the second way. Now we eliminate edge BD. This makes vertex B of degree 4 and vertex D of degree 4 as well. So the only 2 vertices of odd degree are A and C. So this is the third way. Now let's remove the edge CD, the straight one. This makes vertex C of degree 4 and vertex D of degree 4 as well. The only vertices of odd degree are A and B. So this is the fourth way. Now we are going to remove the edge CD, the curved one. Again, this makes vertex C of degree 4 and vertex D of degree 4 as well. So the only vertices of odd degree are A and B. So this is the fifth way. So the answer we are after is option A, 5. From the 2017 VCAA examination report, 29% of the students chose the correct option, with various percentages of students choosing one of the incorrect options. Question 7. A graph with 6 vertices has no loops or multiple edges. Which one of the following statements about this graph is not true? To answer this question, we are going to look at each option one by one. Option A. If the graph is a tree, it has 5 edges. We know that the number of edges in a tree is 1 less than the number of vertices. So there are 6 vertices. So the number of edges is 6 minus 1, which is 5. So this is true. Option B. If the graph is complete, it has 15 edges. In a complete graph, the total number of edges is equal to n bracket n minus 1 divided by 2, where n is the number of vertices. And this gives us 15, so this option is true as well. Option C. If the graph has 8 edges, it may have an isolated vertex. Now here are the 6 vertices, and now let's connect them with 8 edges. Notice that one of the vertices is isolated, so this option is true as well. Option D. If the graph is bipartite, it will have a minimum of 9 edges. Notice how this bipartite graph has 3 edges, so this option is not true, and this is the answer to the question. Let's check option E as well. If the graph has a cycle, it will have a minimum of 3 edges, and this is true. We can draw a cycle with a minimum of 3 edges. From the 2017 VCAA examination report, 26% of the students chose the correct option, and various percentages of students chose one of the incorrect options. This question was not completed well. An effective way to solve this question was to check each option separately with the aid of a diagram. Question 8. The flow of oil through a series of pipelines in liters per minute is shown in the network below. The weightings of 3 of the edges are labeled X. Five cuts labeled A to E are shown on the network. We are asked to determine which one of the cuts gives the maximum flow of oil from source to sink in liters per minute. So we need to determine the minimum cut. Let's look at cut A. We can write that the flow into the cut A is 11 plus X plus 10 plus 4, which is 25 plus X. The flow into cut B can be written as 7 plus 2 plus X plus 10 plus 4, which is 23 plus X. The flow into cut C is equal to 7 plus 2 plus X plus 8 plus 3 plus 4, which is equal to 24 plus X. The flow into cut D can be written as 5 plus 3 plus 5 plus 9 plus 10. So the flow into this cut is 32. And now we are going to look at the last cut, the flow into cut E, which is 5 plus 3 plus 9 plus 10. And this gives us a total of 27. When X equals 1, cut A is 26, cut B is 24, so we can cross this one out because this is not a minimum cut. Now, when x equals 2, cut A is 27, cut B is 25, and cut C is 26, with cut D 32 and cut E 27. So this one is true because the minimum cut is cut B 25. The maximum flow of oil from source to sink in liters per minute is given by the capacity of cut B. From the 2017 VCAA examination report, 44% of the students chose the correct option, with various percentages of students choosing one of the incorrect options.